Hi there. Well, I thought I'd go ahead and get out some information on section 7.4, the addition and subtraction of these expressions with unlike denominators. So we'll have to get a common denominator, and then we'll go ahead and get equivalent fractions that have the same denominator, and then add or subtract the numerators. So then once we get to that point, it's just like 7.3. There were a couple of problems in 7.3 where you're going to need some of this information. Sorry about that. But you can just kind of go back. It was towards the end of the assignment where you needed to get equivalent fractions. But we're going to go ahead and go through that now. Now, looking up in the box up here, we have add and subtract with unlike denominators. First, find the least common denominator. You know, we kind of went through some strategies in that section 7.3. And then multiply the numerator and denominator, each fraction, by the terms in the least common denominator that it's missing. And we'll go through some of those examples. And then once you have that, it's just pretty much adding or subtracting the denominator or the numerators. Well, let's go ahead and get started with some examples. All right, so we've got these first two fractions. I want to add them together. They have different denominators, so we need to get find the least common denominator between 8 and 12. Now, some of you can look at that and say, well, 8 and 12 both go into 24, and so you would just say, I'm going to use 24. But if you didn't know that, we'd have to break them down into primes. And let's go ahead and do that. I'm going to go ahead and copy this. I have a new camera, and it seems to be a bit clearer than the other one was. So this is, it's awesome that the college got this. All right, so what I'm going to do is I'm going to look for the least common denominator of 8 and 12. And I'm going to come over here and do that. 8 and 12. Now the 8 is 4 times 2, and 4 is 2 times 2. So the 8 is 2 cubed. Okay. Now we're also going to go to the 12. Now 4 times 3, 2 times 2. So the 12 is 2 squared times 3. So when we do look for the least common denominator, we look for, let's say we have the 2's, and you always choose the highest power. So this would be 2 cubed, would be the highest power here. So our least common denominator involves a 2 cubed, and it also involves a 3 to the first. So the 2 cubed would take care of those two. Okay, it takes care of the 2 cubed and the 2 squared. They both go into that. And then we have the 3 to the first. So whatever appears here needs to appear here. And you always take the highest power of what's ever over here. Okay, so it's all taken care of. This is 8. Okay, make sure you don't put 6. All right, it's 2 times 2 times 2, 3 times, and then you have 3. So we do get 24. And again, some of you probably could have looked at that and said, okay, 8 and 12 go into 24. Okay, now we're going to do what's different that we didn't do in the last section, and that we're going to rewrite these fractions with a common denominator. So up here, it's going to be this step 2 up here. So here, what we're going to do is, instead of this fraction, I'm going to have, I'm going to move this over a little bit. X squared over 8 plus 7x over 12. I'm going to move it over so I don't run into my least common denominator. All right, so if we look here, I know that the least common denominator is 24. So both of these fractions are going to have a denominator of 24. Both of these are. So in order to rewrite the numerator, you ask yourself, what do you take the 8 times to get 24? What do I multiply the 8 times to get 24? And that would be a 3. So if you multiply the 8 times 3 to get to here, you have to take the 5x squared times 3. So if you multiply this times 3, you're going to have to multiply the numerator times 3. 3 times 5x squared. Okay. Now you go to the 12. And if I have to go from 12 to 24, I multiply. I hate to use an X. I might use a dot instead, because otherwise if I use an X for a times, you think it might be an X. Okay. So I'm going to multiply the 12 times 2 to get to here. So I have to do the same thing to the numerator. So 2 times 7x. And then I'll simplify them. So I didn't want to skip any steps. And some of you could probably just go in ahead and write 15x squared over 24, 14x over 24. So now you have two fractions that are equivalent fractions. All right, they actually would have the same size. They've just been rewritten. So instead of these two that didn't have the same denominator, I rewrote those fractions here. If you were to reduce each of these individually, you would come back to the original. So now I can add the numerators together. They have a common denominator of 24. This is a repeat of our last chapter. So we've got 15x squared plus 14x. Now those cannot be added together. One's an x squared, one's an x squared and one's an x. And there's nothing in common to take out. So that would be reduced. So you're gonna have to try to factor that numerator to see, but there you go. There's the answer if you were to add those fractions together. Let's try another one. And maybe, the difficult part might be going from here to here. And just remember that when you want to write an equivalent fraction for this one, you say, okay, 8 times 3 gives you 24. Now, if you didn't know that 8 times 3 gives you 24, just take 24 divided by 8, and that will tell you what you multiply by. 24 divided by 8 is 3, which meant that I multiplied by 3 to go to the 24. So, and then you take that same number. If you multiply this one by 3, you have to multiply the top one by 3. And then likewise with this next one, if you multiply 12 times 2, you're going to have to take the numerator times 2. And then you just kind of multiply that out. And once you have a common denominator, it's like 7.3, add the numerators and see if you can simplify. All right, well, let's keep practicing that. Let's look at this next example. I have 8x and 12x squared. Well, we don't really need to look to see about the 8 and the 12 as far as finding the least common denominator, because we already did that here, 8 and the 12. And we know that 8 and 12 both go into 24. So when it comes to the least common denominator between these two fractions, I know we have a 24. And then we use the highest power on the x's, which would be an x squared. So I'm going to kind of rewrite this just so it's a little bit larger. And I hear the dogs out there. So I'm subtracting these two fractions. That's quite the subtraction symbol. Let me make it a little bit smaller. Okay. So to get a common denominator, I know that I have a 24 because 12 and 8 both go into 24. And I also have an x squared because I have an x and an x squared. And when the bases are the same, you take the highest power. So there's my least common denominator. Try not to make this harder than it is. And again, I encourage you to contact me and we can do a Zoom meeting and I can go through them, if you have any questions at all. Let's start with our first fraction, 7 over 8x. And you ask yourself, what did I do to go from here to here? Because I'm rewriting this fraction as an equivalent fraction. Well, I multiplied the 8 times 3 to get to the 24, but I also needed another x. So I had to multiply this times 3x. This times this gives me this bottom number. So that tells me what I'm going to multiply the 7 by. I'm going to multiply the 7 times 3x. So we get 21x. When I take 7 times 3x, I get 21x. Now, another way to come up with this 3x that I'm multiplying by is to take the 24x squared and divide that by 8x. When I take 24, so you can, to find the 3x, you can always take 24x, your new denominator, x squared, divided by 8x. And that would tell you what you're going to multiply by. So you get 3, and you subtract exponents, so you get 3x. So the 8x times 3x is 24x squared. 7 times 3x is 21x. Okay, let's go to the next one. What do I multiply this denominator by in order to get to this denominator? Well, 12 times 2 is 24. X squared times x squared, well, I don't need to multiply by anything. So all I need to multiply the 12x squared to get 24x squared is a multiply by a 2. That means I have to take the 5 times a 2. All right, so now I'm going to take 5 times the 2 and get 10. So I've written equivalent fractions. So once you've found the least common denominator, to find the numerator, what times the 8x gives me this? That's what I multiply the numerator by. What times 12x squared gives me 24x squared? That's what I multiply the numerator by. So here, now we have a common denominator. So we're going to go ahead and add these two together. They have a common denominator of 24x squared. The numerator gives me 21x, subtract 10. Ask yourself, can I factor that numerator? Is there anything in common that I could pull out that might reduce with a 24? And there is not. There's nothing. 3 and 7, and that's 2 and 5. So you're done. All righty, let's go ahead and try another one. And I'm hoping you start to see a pattern. It just keeps repeating over and over again. You find the least common denominator. What do you multiply to go from here to here? The same thing that you'd multiply to go to the numerator. You always multiply by the same thing. And again, if you don't know how to come up with this by saying, what do I multiply by? You can always use division to come up with that 3x, what you're multiplying by. Okay, it's another way. If you can't, just do that in your head. All right, let's look at our next one. I'm going to put this up here and there. Okay, we're going to find the least common denominator between a squared minus 1 and a squared plus a. To do that, I'm going to factor these two. So here, I'm going to take, well, I'm going to go ahead and put this up here just in case it's a little bit too small for some of you guys to see. Plus 1 over a squared plus a. All right, so here we go. I'm going to factor this. Okay, so that, just like I did the 8 and the 12 up above, I'm going to break it into primes. This right here is a minus 1, a plus 1. It's a difference of 2 squares. This one right here, I have a greatest common factor of a. That leaves me with a plus 1. All right. So now I need to see, I'm going to take everything here is going to appear in my least common denominator. And then I'll redo the two fractions. So I'll have well, let's just come over here and put the least common denominator over here. I'm going to have an a minus 1 and to the first power, because I have an a minus 1 to the first. There's no other a minus 1 to the second or anything like that. That takes care of that one. I have an a plus 1 here and an a plus 1 here. Well, again, to the first power, you take the highest power. So there, so far, that takes care of these. But I have this a here, and it's a to the first. And so I'm going to have to use it as well. And I'm going to put it in front. So there's my least common denominator. Okay, let's go ahead and I'm going to rewrite those with my least common denominator. Sorry about the dogs. I think the UPS man is here. A minus 1, a plus 1. Okay, when you decide what you're multiplying by, rather than looking at the a squared minus 1, look at the factored part. Use those to see, what did I multiply this by to get to here? So just kind of ignore these and use what you had when you factored. So let's do this first fraction. In order to go from a minus 1, a plus 1, which is this the same thing as these two mean the same thing, to go from here to here, I multiplied by an a. That's all I'm missing is an a. To go from here to here, I needed to multiply by an a. I was just missing that first term right there. That means I'm going to take my numerator times the a. So I get 2a squared when I take 2a times the a. And again, if you were to take your new denominator and divide it by this original, the a minus 1's all cancel and you're left with just an a. So let's go to the next one. What did I multiply this by in order to get to my new denominator? What do I need? Well, I've got an a, so I don't need another a. And I've got an a plus 1. It looks like all I'm missing is an a minus 1. So I'm going to multiply by a minus 1. Okay. And I am going to use the parentheses. So I take this a minus 1 that I needed. That's what I'm going to multiply the 1 by. 1 times a minus 1. Okay. And we'll simplify. We're going to multiply this out and see if we can factor it. So let's see, we have our common denominator. I'm going to put it over here. A minus 1, a plus 1 is our common denominator. And I have a 2a squared. 1 times a is a, 1 times a minus 1 is a minus 1. So you're going to have to do some multiplying. Sometimes you may even have to use the FOIL method, but we'll see. And then we have plus a minus 1. And can this be factored? Let's see, it might because of that minus 1. Let's look and see what we've got here. Let's see, you know, there's no guarantee, but unfortunately, we'd probably better try. And then I'll have a minus 1, a plus 1. Well, let's use the guess and check. Let's see, we've got 2a times a gives you 2a squared. 1 times 1 gives you 1. But one of them needs to be negative. One of them has to be a negative. So let's see, let's go with a plus here and a minus here. And let's see if I end up with a plus 1 as a middle term. This is a positive 2a, and this is a negative 1a. Gives me a positive 1a. So it did factor. And it'll cancel. So they're going to ask you to reduce. I did forget the parentheses on this last one. So these two will cancel out. So your answer is 2a minus 1, it's the only one that was left, over a times a minus 1. And I would just leave it like that. I would not multiply that a through in the denominator. So let's recap. We factored, and then we got a common denominator that included everything up here and the highest power. Then we thought, okay, what do I multiply this first denominator by to go to my new one? And it was just the a I was missing, just the a. So I multiplied the numerator times the a. Then I looked to see to the next fraction. What do I multiply this one by to come to my new one? And I needed to multiply it by a minus 1. Okay, so that this times a minus 1 gives you this. So then I take the numerator times that. And in this case, once I added the numerators together because they had a common denominator, I ended up with this 2a squared plus a minus 1. And then I just needed to factor and then reduce. Wow. So this actually had some 7-1 in it as well, factoring and reducing. Okay, let's just keep trying these. This pretty much covers everything. There are going to be a few little tricks that we may have to do on some of these. Let's see. I just have a few more. Yeah, okay. That's all right. Let's look at this one right here. I have two fractions, and this one does not seem to be as in focus as some of the others. Let's see, I'm not sure where my focus button is on this new one. There, perfect. Now I'm going to go ahead and recopy this just in case it's a little bit tough for some people to see. X minus 2. This is a subtraction. We know that, wow, we're going to have to watch our numerator that follows. Sometimes we can mess with the denominator. Okay, if you look here at these two denominators, they don't need to be factored like they did in the last one. They're already factored. So I've got an x minus 2 and I have an x plus 5. So that means my least common denominator has to use them both. I have to have an x minus 2 and I have to have an x plus 5. So here, this is this numerator and this one. So my numerator, my least common denominator is going to be x minus 2, x plus 5. And right now I'm just ignoring the numerator here, just paying attention to the denominators so that everything that occurs in these here occurs in your least common denominator, which it does. So now let's change our first fraction. You ask yourself, what do I have to multiply x minus 2 by so that I get x minus 2 times x plus 5? Well, I have to multiply by x plus 5. If I took this times this, I get this. So that means I have to take the x plus 4 times that same thing. So whatever you multiply the denominator by, you have to multiply the numerator as well. So that you always have to have both of those. So if I multiply the denominator to get to here, I have to multiply the numerator as well. And let's go to the next one. We've got x plus 5. To get to this one, I have to multiply by x minus 2. To go from this denominator to this denominator, I'm multiplying by x minus 2. So you're going to take that times that. So I'm going to take this x minus 2 that I needed here and multiply it by my numerator. This is just that step 2 on the previous page. Oops, 2. There you go. All right, now in order to subtract these numerators, we're going to have to use the FOIL method and multiply them out. And you don't need to do that in the denominator. You can leave the denominator alone, but you are going to have to multiply the numerators. And what I'll do is, I think I'll just go ahead and put that down here. I'm going to use the FOIL method on this first numerator. The first times the first is x squared. 5x and 4x is 9x. 4 times 5 is 20. There's my first numerator. And again, don't do that in the denominator. Minus, and then we're going to multiply these two together as well. And again, we have the same denominator. So I'm ignoring that subtraction. So I'll just go ahead and multiply these together using the FOIL method, the first times the first. Then I have a minus 2x and a positive 7x is 5x. 7 times a minus 2 is a minus 14. Okay. So now I multiplied those together and I have a common denominator. So I'm going to put those over the common denominator. X minus 2 over x plus 5. Now I'm going to have an x squared plus 9x plus 20. Now remember from the last section, this is going to change the sign on everything in here. So now I multiply that out. So now I'm going to have a minus x squared minus 5x plus 14. So again, this will change those signs. So don't forget to do that. Well, let's see. Let's keep going. Now that we've got the numerator, we have to simplify it. So the x squareds, wow, that's nice. The x squareds cancel out. 9x and minus 5x is 4x. I may need to factor, so I'm going to put it over here. And this isn't equal. And then 20 and 14 give me plus 34. All over x minus 2, x plus 5. All right, can you simplify that and cancel it? Well, you could take out a 2, but it's not, see, you could. That would give you 2x in the numerator plus 17 all over x minus 2 times x plus 5. But nothing reduces. Nothing reduces because it has to match. So this is your answer because it cannot be reduced. So again, you get a common denominator. Everything here needs to appear in your denominator. Then you ask yourself, what do I multiply this numerator by to get to this one? And that's the same thing that you'll multiply to the numerator. So I had to multiply by an x plus 5 to get to my new denominator. So I'm going to do the same thing in the numerator. What do I multiply this denominator by? X minus 2. So I take that numerator times x minus 2. And in this case, I had to use the FOIL method in both of these. Okay, these are equivalent fractions. I've made equivalent fractions to the originals. And then I had to be careful of that subtraction because it changed the sign on everything in the following numerator. And then you combine similar terms and see if you can reduce. So there's section 4 here, and then there's section 3 here, and then there's the section 1 and 2 where you have to reduce. All right, let's try another one. And hopefully you'll see this pattern here. Okay, now these we're going to have to do the same thing that we did with the a squared minus 1. We have to factor. You need to factor in order to find the least common denominator because these denominators are different. They don't match. So I'm going to have to multiply. Well, I'm going to have to factor these. let's see, I guess I can copy them over. And so we've got x squared plus 5x, just in case it's not that easy. And look, we have another subtraction. Minus 2, so we have to be careful of that subtraction there and change all the signs in that numerator when the time comes. Okay, so here, let's go ahead and factor, and I'm hoping that you guys are good at it. X times x gives you x squared. 3 times 2 give you 6. Added together gives you 5. Everything we want to be positive. So when we do work, we're going to be using this now. We're going to be using this x plus 3 times x plus 2 from now on. Once you've factored it, we just kind of ignore this other part. And now let's factor this x squared plus 3x plus 2. That's not too bad. So x times x gives you x squared. Let's see, we've got 2 times 1. I wish my parentheses are kind of close there. Give you 2. And we want plus and plus because that gives us our 3x, 2x and 1x with the FOIL. So let's go ahead and let's find our least common denominator. When I do that, and I think I might just go ahead and just rewrite those. I don't know how much room I'm going to need, but I'll just give lots of room. So I'm going to write equivalent fractions for both of them. Now, the least common denominator, I've got an x plus 3. So I have to have an x plus 3 as a least common denominator. And the highest power of any x plus 3 is to the first. So that's taken care of. I have to have an x plus 2 because it occurs in both fractions. And the highest power is to the first. If I had an x plus 2 squared, I'd use that. And then I've got an x plus 1. And I have an x plus 1. As a, there's my least common denominator for those. Everything in these originals here is now found down here. Okay, let's look at our first fraction. Let's write an equivalent for this first fraction. In order to go from x plus 3 times x plus 2 to this one, I'm missing an x plus 1. So to go from here to here, I am missing an x plus 1. That's what I multiply by. That means I have to take the numerator times that same thing. So x times x plus 1. So whatever you're missing, that's what you're going to have to multiply your numerator by. So to go from here to here, I needed an x plus 1, so you multiply your numerator times x plus 1. Our next fraction, to go from here to here, I've got an x plus 2, an x plus 1, I need an x plus 3. That's what I'm missing. So I'll take the 2, my numerator, times that same thing I was missing in the denominator. So I'll take 2 times x plus 3. Okay. Okay, so now I'm gonna go ahead and I'm gonna simplify my numerators, and I'll end up changing the sign on that denominator, or on the second numerator. But I'll go ahead and I'm gonna write it over here. I don't know if that affects it, the fact that, there. So my common denominator, I'm gonna write here, times x plus 2 times x plus 1. Okay, this one, when I multiply these together, I have an x squared plus x when I multiply those. Over here, I have a 2x plus 6 in that numerator. I just multiplied. I'm ignoring this subtraction right now. I just multiplied that through. So I'll have an x squared plus x. But now, when I'm combining these, that's going to be a minus 2x, because that becomes a minus there, and a minus 6. So that will change those. So it's a positive 2x here. It'll make it a minus 2x minus 6. So my numerator is x plus 3, x plus 2, x plus 1. Again, don't multiply that denominator out. And then we've got x squared minus x, because positive x and a minus 2x is a minus 1x, minus 6. Okay, perfect. Now, let's see if we can factor and reduce. So let's see if I can factor this and see if it reduces. I might factor it up here above it. Let's see if I can factor. X times x gives you x squared. 3 times 2, one of them's going to have to be negative, and we'll make the bigger one negative because I want a negative 1. Negative 3x and 2x is a negative 1x. So it did factor, and what can cancel? Well, this is x minus 3, and that's an x plus 3, so you can't. They're not the same. But these two x plus 2's will cancel. That leaves you with an x minus 3, x plus 3, x plus 1 as your answer. Okay? So again, you get a common denominator, and then I would multiply. You may want to multiply these out and then change the signs after you multiply them to come over here to combine your numerators, and then factor if you have to or if you can, and cancel. All right, well, let's just keep doing some samples. Let's try another one. Let's look at this one here. I've got 8a and a negative 8a. So let's look. Let me see, we have 3 over 8a. This camera is so much better, but I'll just go ahead and... Common denominator, 8a. Okay. 8a. I'm going to ignore that negative until I see what I'm multiplying by. So to go from here to here, you multiply by 1. Just a 1. 3 times 1 is 3. Okay. To go from here to here, you multiply by a negative 1. So that's when you can pay attention to the negative. And so you take 3 times a negative 1. So when you add your numerators together, because you have a common denominator, you get 3 plus a negative 3, which is 0. And whenever you have a 0 in the numerator, your answer is 0. Now, if the 0 had been in the denominator, which it wouldn't be when you're adding, but if it, if that ever happens for some reason, then it's undefined. But if it's in the numerator, your answer is 0. So what you're doing here is you're taking a fraction and adding its opposite. It would be like taking 4 plus a negative 4. Okay? You're going to end up with 0. Okay? All right, so the answer is 0. If you recognize that fact, or if you went ahead and found this getting the least common denominator and then adding the numerators, either way, you come up with 0. Well, that one didn't take too long. Let's try another one. There's 2 on this page. So here, looking at this is 5x over x minus 7. And now they're subtracting 3x over 7 minus x. All right. These two denominators, even though I didn't really write that one very well. like that. Start again. Okay. These two are equal and opposite. So we have x minus 7 and a 7 minus x. A positive x, a negative x. A negative 7, a positive 7. So both, there you have opposites with both numbers. So what I'm going to do is I'm going to rewrite this one. So this is going to be 5x over x minus 7, 3 over a minus x minus 7. Okay? So these two mean the same thing. Now, when you have two negatives like this, it's a positive. A negative and a negative is a positive. So this is actually 5x over x minus 7 plus, did I forget an x on my 3? Yes, I did. Because we haven't even really looked at the numerator. 3x over x minus 7. So if you ever have to switch this here so that it matches this one, okay, it's going to require bringing out a negative, because if you were to multiply this, you're going to come back to this one. So this and this are the same thing. So then you have these two negatives here, which is a positive. So your answer, so now we have a least common denominator. So again, if you switch them around, you're going to have a negative. And if it is a subtraction, it'll become a positive. Maybe, yeah, we can look at another one in our next problem too. So our common denominator is x minus 7. And we have 5x plus 3x, which gives us 8x over x minus 7, which cannot be reduced. So you can switch things, but then if you do, you have to have a negative out here. And so whatever that is, two negatives is a positive. Now, if that had been a positive, so if I would have had 5x over x minus 7 plus 3x, if I would have had this, I would have had 5x over x minus 7 rewriting that fraction there, you could change that to a subtraction. Okay, you could rewrite it minus, because a positive and a negative is still a negative. Okay, that's what it would have been. So you've got these two ideas here, or this one. Okay. So when they're equal and opposite, you can always switch them around, but you're going to change that sign in front of that fraction when that happens. Okay. Let's look at another idea that's similar to that one. That's kind of a tricky thing, but let's practice it. Okay. I have three fractions I'm going to add together. Well, let's start. Let me copy them, and let's factor. Five over 2 minus x over 2 plus x. All right, those factor the first one to find the least common denominator for all of these. This one right here is a difference of 2 squares. And when I'm finding the numerator and stuff, I'm going to be using this one, not this. Oh, it really couldn't be factored or couldn't be factored. But if you look here, this is 2 minus x, and this is x minus 2. So if you look, these two are opposites. So you could change this one to match that one. You can do that. Because if you take the negative and distribute it out, you come up with this one. Now this one and this one here, if you look at these two, these are addition. And so you can just switch this, because order doesn't matter in addition. So you can switch this one, but this one, you have to take out the negative in order for it to remain equal. This is equal to this, but if you switch in subtraction, you do have to bring out. Subtraction, you can't just switch the order. Okay, let's look at our least common denominator now. Now here, this right here and this right here, this is going to become a subtraction. For our least common denominator, that one's going to stay minus. And if you do take these and make it the subtraction right there, okay, you don't have to, but you can, then you can just ignore it when you're trying to find the least common denominator. So those two can become that subtraction there. So our least common denominator is x minus 2. We took care of that one, which takes care of that one. And x plus 2 takes care of that one and that one. So x minus 2, x plus 2, x minus 2, x plus 2. So when you have, again, you know, it might be giving some of you fits, and I can always help you on Zoom, you know, because there's other ways of looking at this. But if you do have to switch the order with a subtraction, just change the sign between the fractions and they'll take care of it. It's gone. So now we'll have to go from here to here, you multiply by 1. To go from here to here, you multiply by a 1, so we'll take 2x times 1, which is just 2x. Now we've already taken care of this negative, it's right here, so we don't have to pay attention to it anymore. To go from here to here, I multiply by x plus 2. That's to go from here to here. And then you take 5 times x plus 2. So once you've taken care of that negative here by switching the sign, it's gone. Now the next one, to go from x plus 2 to here, you multiply by x minus 2. So we'll be taking 1 times x minus 2. To go from there to there, you had to multiply by x minus 2. Okay, let's simplify each of these numerators. Let's see, the 2x is 2x. Multiplying, this is 5x plus 10. And this is 1x minus 2. Okay, so I just multiplied those through. So now I've got an x minus 2, x plus 2. This right here is going to be 2x. Because of the subtraction sign, it's going to be a minus 5x and a minus 10. And the subtraction sign came because I had to switch the order here. So I changed the plus to a minus. If it had been a minus, I would have changed it to a plus. And then then we multiply these, and now this will change their signs. I multiplied these, and so now I'll have a minus x plus 2. Ooh, okay. Over x minus 2. Okay. So I've kind of done my numerators now. You know, I simplified the numerator, and then if I had subtractions, I changed the signs. And now we'll combine similar terms. X minus 2, x plus 2. Let's see, we've got 2x and a minus 5x is a minus 3x, and another minus 1x is a minus 4x. And let's see, we have a minus 10 and a positive 2 is a minus 8. Well, let's go ahead and see if we can factor this. Let's take out a minus 4. So we have a leading coefficient that's positive. That leaves us with x, and then negative 4 times a positive 2 is a negative 8. And the x plus 2's cancel. So we have a minus 4 over x minus 2. Wow. There was quite a bit to that one. But again, if you're just pretty methodical and go step by step, I know there's a lot of places to make a little mistake. I did shorten this assignment by about 3 or 4 problems just because they seem to be a little tedious. But you know, if you're having trouble, you can always just do another one until you know you understand it. Okay, let's do 2 more, and then that will be it. So here I've got, let's go ahead and rewrite these fractions here. Subtract. All right, this first one is x plus 1. And the numerator, we'll just write it. And this x one is x plus 5. And the numerator stays the same. But this next one, I'm going to factor it. This is x times x gives you x squared. 5 times 1 gives you 5. And combined, you get a 6x. So using the FOIL, 1x and 5x. And then I have 5x plus 17. Okay. Least common denominator. Then we're gonna see what we multiply by to come up with the numerators. Then we'll combine things and simplify. So let's go ahead and come up with the least common denominator for each of our 3 fractions. I honestly think this is the hardest section in the whole chapter, is this one right here. Okay, I have to have an x plus 1. Okay, I'm just starting here on the left. So everybody has to have it. That's part of our least common denominator. That takes care of the x plus 1. And then I need an x plus 5. Because I have an x plus 5 up there, and the highest power is x plus 5 to the first. Awesome. That's it for your least common denominator. Now let's write an equivalent fraction with that denominator. So to do that, you ask yourself, what x plus 1 times what gives you this? And you need to multiply this. To go from here to here, you had to multiply by x plus 5. So that's what I will multiply the numerator by, is x plus 5. Looks like we've got to do the FOIL method. Oh well. The next fraction. To go from x plus 5 to this one, I have to multiply by x plus 1. So I'm going to take x plus 7 times x plus 1. That's what I multiplied the denominator by. That's what I have to multiply the numerator by. Let's go to the next one. To go from here to here, I just have to multiply by the number 1. So you can even put that if you want to, 1 times 5x plus 17, because that's what I multiplied by to go from this to here. I wasn't missing anything, just a 1. It's multiplied by 1. So there's our equivalent fractions. And so now in order to add and subtract them, I'm going to have to multiply those numerators out so I can combine similar terms. Let's go ahead and, I keep forgetting this last parentheses. Okay, I'm going to do that here. All I'm going to do is I'm going to multiply the numerators, x plus 1, x plus 5, And hopefully I'll have enough room. Oh dear, I should speed that over a bit. X plus 1, x plus 5, x plus 1, x plus 5. Okay, so all I'm going to do is do the FOIL method on each of these. So that means 2x times x is 2x squared. 10x and 5x is 15x. 5 times 5 is 25. Perfect. Let's go to the next one. X times x is x squared. 7x and 1x is 8x. 7 times 1 is 7. Okay, let's go to the next one. 1 times 5x is 5x. 1 times 17 is 17. Awesome. So now what I'm going to do is I'm going to put them all under x plus 1 times x plus 5 is my common denominator. Let me move this up a little bit. And I'm going to add these numerators together. So this one is 2x squared plus 15x plus 25 plus x squared plus 8x plus 7. Here's the trouble right here. Minus 5x minus 17. And I'm just going to combine similar terms. Okay, we have 2x squared and a 1x squared is a 3x squared. That takes care of those. Let's see, we've got 15x and 8x, give you 23x. And then we have a minus 5x gives you 18x, positive 18x. Okay, that takes care of all our x's. And then we come up with 25, positive 7, and a minus 17 gives you a positive 15 over x plus 1, x plus 5. Wow. So now you need to see if you can factor that numerator. And let's see, it might. When you factor, the first thing you always do, is look for the greatest common factor. So let's do that. 3 goes into all of those. So that leaves me with x squared plus 6x plus 5. All over x plus 1 times x plus 5. Now, we're running into our other one, but that's okay. Let's go ahead and see if we can factor. So we end up with x times x is x squared. 5 times 1 is 5. And plus, that does give you the 6x. X plus 5. So I pulled out the greatest common factor, and now I'm factoring what's left, and it looks like that's a plus there. This cancels, and your answer is 3. Wow. All of that work to come up with a 3. So what did we do? Well, we factored this first, we factored this one right here. Then we got a common denominator. Then we asked ourselves, what do you multiply by here to get to here? And that was x plus 5. That's what we multiplied the numerators by. So we changed our numerators. And then we multiplied these out. Lots of places to make little mistakes. And then we took this plus this, and we remembered that because of the subtraction, we changed the sign on those two. We combined similar terms for all of the numerators, took out a 3, factored it, reduced, took out a 3, factored it, reduced, and you end up with 3. Wow. Okay, last one. You guys are hanging in there. It's awesome. Let's look at our last one. Okay, let's hope it's not quite as, you never know. Oh, it's a little crooked, but okay. Now this one right here, let's go ahead and get a common denominator. I guess maybe the nice thing about this one is that it's the same idea throughout the whole section. This one right here is r minus s, r plus s. Okay, I factored that first one. It's a difference of 2 squares. R squared minus s squared. So our least common denominator is r minus s. That takes care of this one, and r plus s. R minus s, r plus s, r minus s, r plus s. Now, to go from our first fraction, we factored it. To go from here to here, I multiply by 1. I'm not missing anything. So 2r times 1 is 2r. Okay, I rewrote it. It's equivalent. They're equivalent with the right denominator, correct denominator. Now the next fraction, the r plus s, this one I need to multiply by an r minus s. So I got the 1 times r minus s. So whatever you have to multiply the denominator by to get to this new one, you do that, multiply by that same thing in the numerator. Now let's look at this one, r minus s, I need an r plus s. So I'll take 1 times r plus s. To go from this numerator to this numerator, I needed to multiply by r plus s. So that's what I multiply the numerator by. Whatever I need to multiply the denominator by, I multiply the numerator by. That's that step 2 on that first page. Oh, great, common denominator. Let's look at the numerators. This one, 1 times r is r minus s. So when I multiply that through, 1 times r. Okay. So when I do these here, I've got, what is r? My common denominator is still r minus 1, r plus s. So my first fraction is 2r. My second fraction has a plus in front of it, and I multiplied it, so I'll take r minus s. Now this one, my next fraction has a subtraction in it. So rather than r plus s, I'm going to change their signs on both of them, minus r minus s. So there's so again, make sure that you take note of that right there. I don't know if I should, it looks like, oh well, kind of looks like a multiplication sign, but it's not. It just means take note of that. Be careful that when you have that, you go ahead and you multiply this through totally, and then change the signs. So combine our similar terms of our numerators. Let's see. We end up with 3r, and we end up with 2r. So the r's, plus r and minus r, they cancel, so you just have a 2r. Minus s, and a minus s is a minus 2s. Oh, wow. So now let me move this up. I have to make sure I watch that. So here, now all you need to do is factor out a 2. R plus S. So we factor, we're back to our 7172 section. These cancel. And so we end up with a 2 over R plus S. Okay, so that was the last one that I was going to go through for this section. I can't think of anything maybe in the homework that might give you some issues. If some of you contact me with some questions, I can always do another Zoom video and upload it to YouTube for that, for this section. But I've covered quite a bit, and this has kind of gotten a little long. So I just want you to make sure that, you know, it's like on this last one, you know, again, be careful of your subtractions, you know, so that once you simplify, then when you go to combine all of your numerators, when you go to combine all the numerators, that you do change the sign on those. Okay, and just, you know, like I say, there's lots of places. Now to come up with the numerators, you ask yourself, what do you have to multiply the original to get to the common denominator? And you multiply that same thing. Like here in this example, you multiplied by x plus 5, you multiply by x plus 5, the numerator, by that same thing. And then you do the same thing with each of them. To go from x plus 5 to this one, you multiply by x plus 1. So you take that times the numerator. To go from this one to this one, you multiply by 1. And then you use the FOIL method. No? And then you bring down all of your numerators, and again, changing your sign, combine similar terms, see if you can factor it, and which you can, and reduce, and you come up with the number 3 after all that work. Well, you know, I encourage you to contact me, and I'm going to try to put my Zoom room up on the syllabus, but it's also in the Math Center schedule I sent you. You just have to click on my name. My phone number is on the syllabus. You can text me and say, you know, can we meet to go over a certain problem? And I'd be happy to. I'd be happy to, you guys, because I know this is tough to go through all of this. And you hung in there. It was kind of a long section, and I knew 7-4 would be a long section, but like I say, it's probably one of the harder ones, and it shouldn't be as bad through these next ones. Even the story problems aren't going to be too bad. But anyways, and I did shorten this assignment. Okay, please contact me, and I'll try to put my Zoom room up on the syllabus. And then my phone number's there, and probably the YouTube channel link so that you can watch these. Don't forget, well, by the time you watch this, the test will probably be closed. But I'm going to be opening up a quiz that covers these last 4 sections, sections 1, 2, 3, and 4. And you get 3 attempts, so it won't be too bad. I'm going to look at it and make sure it's not too long. So, all right, well, take care and stay well, and communicate with me. I encourage you to do that. Thanks. See ya. Bye-bye. Let's see. Let me pause the video. Share. Pause the video. Let me see how to do